Well, hello again. Here's a video for the Math 96 practice on Otus. So what I'd like you to do is log on to my.otus.com, complete this practice. We're going to test on Friday. If you need help on an item, then you can come back to this video and I do each item separately, and you can kind of advance the video to whichever one you need. Or you can listen to the entire video if you want to. And then if Mrs. Hanvey is in class today, again, you can also ask her for help. All right, here we go. So item number 1. So what you want to do in rationals is you want to check and make sure you have either like or unlike denominators. So these are the like denominators or same denominators. So we just go ahead and bring over our denominator, our common denominator, and then check to see if you have add or subtract. So be careful on the subtract. You have to distribute this hidden -1, which means what we're going to do is we're just going to change the signs on both the 6x and the 5. Okay? So I'm going to bring over our first two items, 8x plus 9. And then I'm going to distribute -1, and it just means where I have a positive 6x, I write -6x. Where I have a positive 5, I write -5. That's all you do for this. The subtract is, think of it as distributing -1. And then we're going to collect like terms on the top. So 8x's minus 6x's would be 2x's. And then, of course, 9 minus 5 would be 4. And keep your denominator. And then check. Can you factor? And you can. This is GCF box factoring. So for 2x plus 4, you put the 2x and the 4 in. You can take out a 2. What would you need on top? An x and a 2. And you can do the same for the bottom with the 2x plus 6. So this would change to 2x plus 4. And you can also pull out a 2 from the 2 and the 6. So that would leave an x and a 3. It would be x plus 3 in the bottom. So you do have to check all the time for factoring and reducing. That's what we do with fractions, is we reduce at the end. And the reason we did that is because we could cancel 2's. So our final answer would be whatever's left. And in this case, it's, oh, you guys, I made an error. Sorry. I'm not going to start the video over. There should be a 2 here. There we go. Sorry. X plus 2 in the top and x plus 3 in the bottom. All right, so that's our final answer. Next one, item 2. So in this case, we have different denominators, so we have to make sure when we're adding and subtracting fractions that we have a common denominator. So you take one of everything, so I need the x plus 5. I also need the x minus 3. And what you do is you multiply the tops by whatever's missing. So the first fraction, if you compare your denominator to the CD, the first fraction is missing x minus 3, so that's what we need to multiply the top by. If you look at the second fraction and compare to the CD, it's missing the x plus 5. So we're going to multiply the top by x plus 5. All right. We're going to draw our equal sign. We're going to put our common denominator there. And then we're going to start with the top. So if we distribute here, 3 times x and 3 times a -3 would be 3x minus 9. And now, when you multiply a binomial to a binomial, I did show you in class how you can multiply 2x to x plus 5. And when you're done with that, multiply 1 to the x plus 5. Or we also did this rather successfully with the box method. And you just take the 2x plus 1 and the x plus 5, and you multiply into the box. We'll take x to 2x, x to 1, and then go across 5 to 2x and 5 to 1. And that's how we can get our answer. So you can either do it by FOIL or double distribute, which is up here with the arrows, or you can do it by the box. So this would be 2x squared plus 1x plus 10x plus 5. And then remember, this is the front of your answer, this is the back, and you add up the diagonal. So the final answer would be 2x squared plus 11x plus 5. And then I'm going to write that up on the top here. I'm going to go ahead and erase that box work so I have more room. All right, so the next thing is to collect like terms up in the numerator. So what do we have here? We have a 2x squared, and then we have 3x plus 11x, 2x squared plus 14x, and the last thing we have is negative 9 with positive 5. That's a negative 4. And then make sure you keep your denominator. Okay, and then you want to double check, can you factor the top? Because we might be able to factor and cancel. So ask yourself, is there anything that multiplies to a negative 8 that gives you 14? The answer is no, so we're done. And this is everything that you would type in for your final answer on Otus. And make sure that you don't use capital X's on Otus because it marks it wrong. Okay, onward to item number 3. So this is a complex fraction. First thing we need to do is find a common denominator. Right here we need to factor wherever we can. This is GCF factoring. Everyone has the back amount of x's. So we would change this fraction into the denominator into x times x minus 1. Keep going. And our common denominator is 1 of everything. So I need the x minus 1. And over here, I also need the extra x that's on the outside. There's nothing else here. So we have 1 of everything. Now you multiply the tops by what's missing. And so for this first fraction, x is missing. The second fraction, nothing is missing. The third fraction, the x is missing. And the last fraction, the x is missing. Now there's a trick. So once you go ahead and multiply the tops by what's missing, you can wave out these denominators. Draw your equal sign in your bar. And just do the tops and put it there. And just do the bottom and do it there. Okay? So on the top we would have 4x plus 3x plus 1. And on the bottom we would have 3x squared plus 1x plus x squared. The next thing we need to do is collect like terms. So on the top we would have 4x and 3x is 7x plus 1. On the bottom we would have 3x squared plus 1x squared is 4x squared plus 1x. Now we could factor a GCF on the bottom. We could take out an x. That would leave us with 4x plus 1. But that doesn't help us because nothing in the top would cancel, so we don't do it. So our final answer would just be 7x plus 1 over 4x squared plus x. Okay, moving on to item number 4. Item number 4 is to solve. To solve an equation, you also need the common denominator. So we want to check, make sure we factor everywhere before we find the common denominator. So what multiplies to 24 and gives us 10? Oops, sorry, I was writing what I was saying. What multiplies to 24, 6 and 4, and gives us a negative 10. Would be negative 6 and negative 4. So this fraction's denominator is replaced with the blue. So 1 of everything, x minus 4, x minus 6. We already have those over here. Multiply the tops by what's missing. So this top is missing the x minus 6. This top is missing the x minus 4. And this top isn't missing anything. And now when you solve, you automatically wave out the denominators after you multiply the tops by what's missing. You only take care of the tops. And don't forget you have an equal sign. So I'm going to distribute here, and I'm going to distribute here. So 5x minus 30 plus x squared minus 4x is equal to 2x. And now what you want to do is get this to be equal to 0. So I have to pop this over. So I'm going to subtract 2x to both sides. We'll put it underneath this one. Now I have equals 0. So I'm going to start with x squared. I have 5x minus 4x minus 2x would be a negative 3x. And then I still have minus 30 in the back. And now I need to factor and solve. You can hit pause on this video if you need more time to write. Okay, so we want to ask ourselves what multiplies to a negative 30 and gives us 3. Let's see here. 1 and 30. I'm looking at the yellow chart. Well, I don't have one. 3 and 10. 5 and 6. Did I make a boo-boo here? I did. You guys, I made a boo-boo, and I'm not going to redo this whole video for a boo-boo. There we go. 5x minus 4x is 1x minus 2x is negative 1x. There we go. So what multiplies to 30 and gives us a negative 1? We would have to have a 5 times negative 6 is negative 30, and a 5 minus 6 is negative 1. Okay, so I can factor this. X, what multiplies to 30, 6 and 5, gives us negative 1 would be a negative 6 and a positive 5. I'm going to move this up. I'm going to solve each one. X minus 6 equals 0. X plus 5 equals 0. So add 6, add 6. X equals to 6. This one would be subtract 5, subtract 5. X equals negative 5. And now I have to check for restricted values. So would 6 and would -5, would that create zeros in the denominator? That's what you're checking. So if I put a 6 right here, this would say 6 minus 6, which is 0. That would have a fraction over 0, and that is not allowed. It would be x over 0. So what that means is I have to eliminate the answer x equals 6. How about -5? If I put -5 here, that would be fine. It would be -5 minus 4 is -9. So that's okay. What if I put a -5 here? That would make -5 minus 6. That would be -11, and that's okay. The only one that failed was when x was equal to a regular 6. So I have to exclude that. The only answer I'm typing into Otus is -5. Okay? So it's called an excluded answer for the 6. And the only valid answer is x equals -5. Okay? All right. Hit pause if you need more time. I'm going to move on to item number 5. So this one says, do not solve, only find the restricted values. So I'm going to factor this one. What multiplies to 18 and gives us 9. So x and x. I don't know what I wrote there. There we go. I could barely read it. What multiplies to 18 and gives us 9. That's 6 and 3. Both, let's see. That would have to be both negatives because you need a -9. Okay. So there's all my factors of the denominator. So you set each one equal to 0. Equal to 0 and solve. So x minus 3, this one, equals 0. If you pop that 3 over, it would be positive. So one restricted value would be 3. The next one would just say x equals 0. Oh, and this says to list your answers. List answers from smallest to largest. So I'm going to put my answers in last. And then the last one we need is the x minus 6, because we've already done x minus 3 right up here at the top. So this is the last one. So x minus 6 equals 0. To pop that over, we would add 6. So our 3 restricted values are x equals from smallest to greatest would be 0, 3, and 6. If you don't go from smallest to greatest, Otus is going to mark you wrong. Okay? So like the last problem where we solved, what we're looking for is you could not include 3 as a valid answer because right here it would say 3 minus 3, which is 0 in a denominator, which is not allowed, right? So that's what restricted values are. Let's do the next one. Item number 6, let's factor this real fast. We're only looking at denominators, so what multiplies to 54 and gives you 3? X, 9 and 6. I need a positive 3, negative 6. So these are the only two that we need to check. And solving just means isolating for x. So x cannot be 6 and x plus 9. So this one would be minus 9 to both sides. And then list your answers from smallest to greatest. So the restricted values that you would not be able to include are -9 and 6. Okay, item number 7. Solve. So we need a common denominator. So I'm going to factor this really fast. X. 1 multiplies to 27 and gives us 12. 9 and 3, I need a negative 12, so they both need to be negatives. Oops. Alrighty, remember this fraction is over 1. This fraction has the denominator of x minus 9. Our common denominator needs 1 of everything. Now you don't write that denominator of 1. It doesn't, because multiplying by 1 doesn't change it, right? So we need the x minus 9. We have x minus 9. We also need x minus 3. Okay, the next step is to multiply tops by what's missing. So the first fraction is missing both x minus 9 and x minus 3. So what the first fraction needs to be multiplied by is all of this. So I'm going to put x squared minus 12x plus 27. And then the second fraction is missing just the x minus 3. And the last fraction has both. So now I'm going to do my equal sign and my big bar. On the top, I need this whole thing, because multiplying by 1 is not going to change it. 12x, 27. Second fraction would be 2x minus 6. Sorry, not a big bar. Equal to, and the last one doesn't need anything except write down x plus 3. Now I need to collect like terms. And I'm going to wave out my denominator. When you're solving, you wave out the denominator and remember to have your equal sign, okay? Let's see here. I'm going to go ahead and move this over. So I'm going to subtract x, and I'm going to subtract 3. So I'm going to subtract x here. I'm going to subtract 3 from here. So this would cancel equal to 0. I'm going to bring down the x squared. And then I'm going to check here. I have negative 12x minus 1x is 13x. Negative 13x plus another 2x. So that, let's see, am I right? Yeah. So that would be negative 11x. And then I have 27 minus 6, which is 21, minus 3. Change color. Is, I was at positive 18. Okay, now we have to factor and solve. So what multiplies to 18 and gives us 11? X, 9 and 2. 9 and 2 multiplies to 18 and gets us to 11 if we have both as negatives. If we were to solve that, we would get x equals 9, x equals 2. I'm going to erase all my work from up top. Check for restricted domains. So right here, would I be allowed to plug in a 9, or do I get 0? No, I would get 0, right? 9 minus 9 equals 0. So that answer has to be removed. And the only valid answer, final answer, is x equals 2. Okay, one more. This is item number 8. One more to simplify. We need a common denominator. Actually, nope. This is the one that is the easy. It has an easy trick to it. So we're going to go ahead and we're going to write down this fraction. This bar right here stands for divided by. So top divided by bottom, right? Top divided by bottom. So I'm going to go ahead. I already wrote the top. I wrote the division. Now I'm going to write the bottom. And then I'm going to do freeze, change, flip. So I'm going to leave x squared minus 1 alone with the x squared minus 5x minus 6 in the bottom, and then I'm going to flip the back fraction. Freeze, change, flip. Now I'm going to go ahead and factor. So I'm going to factor here first. That would be the square roots. Remember, you can square root 1. X plus 1, x minus 1. I'm going to write this one on the top. I'm going to factor here what multiplies to negative 6 and gives us a negative 5. That would be x, 6, and 1 should work. So we need a negative 6, positive 1. Yep. And then this one is GCF, factoring with the box. Everybody has a 5, so I can take out 5. X plus 5 would be on the top. So 5 with x plus 5. Okay, next step is to cancel. So x plus 1, x plus 1, x minus 6, x minus 6. And our final answer then would be whatever's left. So we have x minus 1 in the top, right here. And in the bottom, 5 with x plus 5. Okay, I would suggest one more day of practice, and we'll be testing on Friday. Thank you.